yesterday?
Symbolic data.
Symbolic data. So Vishnu, can you explain me what is meant by symbolic data?
Ma'am, like something like n or like names when we give, we needn't always substitute it with a number. Like we if we want to take it as a symbol, like take n as a symbol or take a string as a symbol, we basically give a single quote before it and take it as it is. So
Variable as a data. That variable as a data. So, for example, I may have a name, or I want to have I want to do differentiation, integration, many applications, in which the variable has to be treated as a data. That alphabets has to be treated as a data itself. So we have to go for symbolic data. So the Lisp language is providing some facility. We can differentiate between the normal variable and the symbolic data. So in the case of a symbolic data, that variable has to be, I can't say it is a variable, that data has to have a prefix of single quote. That's what we discussed. So let me share my screen. So let's discuss about one important application of symbolic data. Okay, is my slide is visible?
Yes, ma'am.
Yes, ma'am. Yeah, thank you. Okay, so we all know about the differentiation. There are certain rules, when you want to differentiate a constant with respect to some variable, what is the value?
0.
0 is. If you want to differentiate with the same variable, for example, dy by dy, dx by dx,
Then it's
what
1.
is the value? It is 1. Yes, you are right. So this is a very basic one. And if you take arithmetic operations, we can take addition, d of u plus v divided by dx. What is that? Okay. And we also have a product rule, summation rule, product rule. So that is what we are going to discuss, how to do it. And for this, we need to go for a symbolic data. Okay. So now we know, given a expression and given a variable, we can differentiate with respect to that variable, the expression, right? Okay. So now example, let us take an expression ax square plus bx plus c. We need to differentiate with respect to x, where x is a symbol, it is not a data. The interpreter should not substitute the data. So x is a symbol. With respect to x, you have to differentiate the given. So we know the rule is 2ax plus b. This is the answer, isn't it? So now let's go for differentiating the constant. So dc by dx, where c is a constant, for which the value is, after differentiation, we will get a 0. Differentiation of a constant will give you a 0, or differentiation with respect to a different variable than the denominator. For example, I have dy by dx, it's also 0, isn't it? Okay, this is the first one, you know already. Then dx by dx, differentiate, and if you look at numerator and denominator, both are same with respect to the same variable, then the answer is 1. Okay, let's go for this is a very basic funda. And if you move on complex, d of u plus v. Given two variables, we need to differentiate with respect to x. So what is that? Is nothing but du by dx plus dv by dx. So take each and every variable separately, do the differentiation operation and then sum it up. Okay. If you take a product, the product rule for a differentiation is take u and then differentiate the v variable with respect to x, and then take a v variable, okay, that one as it is, and differentiate the u variable, and after that you have to sum it up. Okay. So now this particular operation, for this we need to write a program. So let us say I want to have a procedure name as differentiation. Okay, for a differentiation, what is the input? What are the inputs you need? One is the expression, another one is with respect to which variable. So I'm going to write a procedure which will take an expression as one variable, and the symbol that is, that will be another variable. Okay, so inside I want to perform 4 operations, right? So I will be just checking, I will use cont, and I check that is it a constant. First of all, my condition will be, is it a constant or it is a different variable? Okay, and moreover, I'm passing to the program 2 arguments. One is the expression, another one is a variable. First of all, if you are not giving x, that is a variable, a symbol, then we cannot able to differentiate. For example, you give 5. With respect to 5, we can't differentiate. So all the test cases I have to incorporate in my algorithm, isn't it? So one of the test cases, the second variable should, the language has to provide you some procedure which will take an argument and check that argument is symbol or not. That is required, isn't it? So in the list, we have symbol question mark. That procedure is available that will check the given argument is symbol or not. Very fantastic, right? Yeah. So then another thing is the second condition. Whether you are giving the first expression, that expression you are just giving a constant, just to say 10 or 100, right? This is a variable and I just give you a constant. If it is a constant and this is applied, differentiation of a constant with respect to a variable is equal to 0, right? This is one test case, isn't it? So I have to write a statement. The basic operations has to be neatly coded, right? So dc by dx constant and the second argument is a symbol, then I will just return 0, isn't it? Okay, so this is the second operation I have to perform, and move on to the next condition. The numerator, that is whatever you are giving, the expression, you just say it is x, okay, and you have to differentiate with respect to x. So both are similar, both are referring the same. That means for the procedure, argument 1 is a variable, that variable is equivalent to the next argument. Okay, both are symbol, but both are equal. Then I will return 1, isn't it? Right? What I'm saying is the first argument for the procedure is a symbol. Okay, that symbol is equivalent to the symbol of the second argument. Okay, so in that case, I will return 1. So how many testing I have done? That is, I will write if, or I will go for the cont, right? So cont is the best one. Now, the second, for the cont, the second condition is this one. Expression symbol, I say the first argument is a symbol, second argument is a symbol, but both are same, both are equal. In that case, I will return 1. And then I will move on to the next operation. The next operation, what it is, I have to identify, isn't it? Whether it is a summation or a product. Your given expression can have a summation or a product. So what you have to do? You have to check whether it is a product or whether it is a sum. So you have to write a procedure called as sum question mark. Okay, you have to write it that will check any plus your first argument. If that is a plus symbol, then you have to do the summation. And for the summation here, this u variable has to be taken out and then differentiate. And the second variable has to be taken out and then you differentiate, isn't it? So you must have a procedure for filtering the data. The filtering operation has to extract only one portion. If the first argument is called as augment and addend, right? The second one is addend, augment and addend, right? So you have to write a filtering function which will just take u alone, and another function which will take v alone. Do the summation. Okay. Now go to the product. This product, if you look at multiplicand and multiplier. So you have to write a procedure which will extract only so multiplicand and then derivative of the multiplier, right? And then take the multiplier and the derivative of the multiplicand, and both has to be summed up. So we need a filtering procedure which will retrieve only the multiplicand and only the multiplier. So we need some basic blocks in order to write a complex procedure, right? So if you write for each and every operation required, we can integrate it as a big procedure, isn't it? Okay. So let us consider what are the functions we require for doing these operations. What I have, I'm just concentrating on these four. These four only I'm concentrating, and other things I'm not concentrating. So now for doing this, what are the basic blocks required? Okay, so these are all the basic functions required. So let us in a Lisp language. So if you take the first function, variable question mark e. So given the expression, you have to check whether it is a variable or not, right? So where it is required, that is the second argument. If you take the second argument, it should be the variable, isn't it? Right? So I will check whether this is a variable or not. What is meant by variable? Variable means it is a symbol. Definition of the variable is nothing but symbol question mark e, so which will return you true or false, right? So that is what I expect. So variable question mark and e, given the argument, okay, it has to return you true or false. If it is false, we can't proceed further. The second argument is not a symbol, we can't proceed. Okay, so that is what this particular thing is required. So let us take how to define this variable. Okay, you just see question mark is the procedure name and x is the argument, and the body of the procedure is, what is that? Symbol question mark x. It will, this symbol question mark is the built-in procedure which will check the argument is symbol or not. The argument what you are passing is a symbol or not. It will return you true or false. Okay, I hope you understood this one. The meaning of a variable question mark procedure. Variable question mark procedure is which will test the argument whether it is a symbol or not, and will return you true or any doubt in this? Students, are you there? Yeah, please give some echo. That's why.
No doubt.
Yeah. Okay. Right. The next procedure, what we want to solve this problem, differentiation problem, is Same variable. I want to check given two variables, both are same or not. Okay. So what is meant by that? Why we require here? Why we require here? X by dx, both are same. Then I will return 1. So for doing this operation, I need same variable of the first argument and second argument is same or not. I have to check it out. So let us define how to define this. How to define same variable question mark procedure. Let's look at. Okay. So same variable question mark v1 and v2 are given. Okay. What you have to check? First of all, v2 should be the symbol and I have to check both are equal or not, isn't it? So there are multiple conditions here. So that's why I'm writing an and. Variable question mark v1. Variable question mark v1. v1 is a variable or not. So this will call the previous procedure. And in which what we have symbol of x. The x is symbol or not, it is checking. So variable v1 will call same variable question mark will call the variable question mark procedure. Previously what I have written, it will call this. So now the symbol question mark x, that means symbol question mark v1, it will be checking. So it may be true or false. And then v2 is a symbol or not. It may give you true or false. And again another condition is v1 and v2 both should be equal. Isn't it? So equal is a predefined procedure we have used already. We are familiar with this. So this is AND condition. So same variable, the v1 and v2 are same variable or not. So in order to check, we require 3 conditions. v1 should be the symbol, v2 should be the symbol, and both should be the same symbol. Right? So that's why there is an AND condition here. Okay. Is there any doubt in this? How to check given two variables are equal or not? You may give variable or you may give constant, whatever. So first of all, you have to check whether it is a symbol or not, and then you check whether both are equal symbol by using equal question mark procedure. Okay, so now the next procedure. Let's take a smaller one. AddIn E. AddIn E. AddIn E in the sense, given A plus B or plus AB, you should be able to extract the AddIn part, the first part of the summation, second part of the plus operator. So 2 operands you will pass. The first operand AddIn, second operand is called as a AddIn. So how to extract? And before that, we need some E. So this expression is a summation or not. I say U plus V, right? Or I may write UV is a product. U plus V, so it is a sum. So the procedure, how it will identify whether it is a sum or not, isn't it? That means you have a plus symbol in your expression or not, that you have to check. Okay, so these procedures we will just look at how to define this. Okay, let's take a sum x, given the expression, whether it is sum or not. So what you will do? What you will do, after all, the x should be the pair, isn't it? Pair means what? You're writing plus A, B, C, etc. Right? So that is a pair, right? So the x should be the pair. And then the car of x should be equivalent to plus. Then you can conclude that it is a sum, isn't it? So now there are 2 conditions here. The given expression should be the pair for the sum, okay? And the pair, the first operand should be the plus. So the first car x will give you the first operator. That operator is that whatever you are retrieving, that is equivalent to plus symbol or not. So just see here the quote is plus. That means it is a plus symbol or not. If it is, then then sum will return you true. Okay, so I hope you don't have any confusion here. The sum function, which will be checking two parts. One is x should be the pair, and then in the pair, the first should be the symbol of what? Plus. The first data should be the plus symbol. Any doubt in this? Okay. So now let us write AddIn and AUGInt. How to extract the first operand, how to extract the second operand. So if I say, so you have written as plus and then let's say u and then v. So now this AddIn part, how to retrieve. So given the expression AddIn of s is what this expression, and from that you have to fetch u, and then for the AUGInt you have to fetch v. So how will you do? That is, we have to go for our famous filtering function, the combination of car and CDR. So this AddIn is a second part. This is the second element. How to retrieve the second element? That is a CDR. The CDR will give you both, and then you have to apply the car to extract the second alone. Isn't it? So that is what written here. CADRS, which will fetch you the second operand from the expression, from whatever you are passing. Then how to extract the AUGInt. AUGInt is a third part. So you know you have to apply the CDR first. CDR will give you U and V, and again apply CDR so that you will get a V, right? And then apply car to retrieve only the symbol V. So that is what we have defined here. Understood? AddIn and AUGInt procedures are nothing but a combination of CDR and cars. Okay. So now let's go for another procedure. What are the other procedure? Make sum. Given two arguments, you just say make sum A1, A2. We have to construct a sum of A1 and A2. What is meant by constructing a sum of A1 and A2? That means I have to construct like this, plus and then A1, okay, and then A2. This one I have to construct. So your Lisp interpreter, it will, whenever it is executing this particular statement, it will add it, isn't it? So I have to write a statement which will construct a expression like this. So I have a make sum which will take two arguments A1 and A2, and then construct a list which has plus then A1 and then A2. Okay, so how to do that? Okay, see here, define make sum A1, A2. What you have to do? You have to construct a list. Constructing a list in which the plus symbol will be the first data, so that you have a single quote plus and then A1 and then A2. So A1 is here and then A2 as a next data for a list. Okay, isn't it? Now another thing is, while doing a product differentiation of UV, right, on which you have to check whether it is a multiplication or not, you have to construct like this. Make product is another function which we require. Make product of passing two arguments. We have to construct a list with star as a first operand, and then M1 and then M2. So this list you have to construct. Okay, so by using the list keyword, you are constructing this one, isn't it? Okay, so now this is sum is over, addend is over, argand is over, and then let's check whether you have to provide, that is you have to check product or not. We also checked whether you want to do the plus symbol, that is a summation, or you want to perform product. So this is another task. For some we already have written. This is the one. Some x, given an expression, what is the operation it demands? It demands plus or it demands multiplication. So sum is defined like this. Whether you have a product or not in the given expression. So product and given expression, first of all it should be the pair, and then in the list the first operator should be the multiplication. So car of x will retrieve you the first operand, and the first operand is equivalent to the symbol star. That is what we are doing it here. So the product question mark is a procedure which will do two tasks. One is the given argument is a pair or not. It must contain more than two elements, or yeah, it should be two elements, right? The first is the operator and then operand and the another second operand. So it is a pair or not, and then the first operand is multiplication or not, it is checking. Okay. And then other filter parts. For the multiplication, we have to extract the multiplicand and the multiplier, right? So multiplier is nothing but the car and the DDR combination, and the multiplicand you can use this CDR and the car combination. So you can extract the first data, that is the second data, and here this is the third data from the given list. So you are only making a okay, and then for example you had m1 and then m2, right? Make product, this is what you have done, right? So after constructing you should extract m1 separately, m2 separately. So how to do that? This is what. So now all the building blocks are over. We have constructed, we have defined. Now let us write a solid algorithm for performing differentiation. Okay, so here what we are doing is define. My procedure name is derive. You can also have differentiation, whatever. And for this, there are two arguments we are passing. One is the expression, another one is with which variable, with respect to which variable you have to differentiate the given expression. So there are two variables here. So to which variable, with respect to which variable you have to differentiate, that is the second argument, and the first argument is the expression to be differentiated. Okay. So inside we are using the cont, so there are multiple cases are coming up. Okay, the first case. What is the first case? Take an expression, okay, and this expression is a number. If the expression is a number, and then return 0. Yeah, this is the first case. Okay. Second case is the expression, okay, is a variable or not. The expression contains variable or not. Okay, so if it is a variable, right, then we are just checking that the expression is equivalent to the second operand or not. If both are same, and then return 1, otherwise return 0. Yeah, so dx by dx or dy by dy, right? So both are symbol and both are equal, then return 1, otherwise 0. We can't differentiate, the value is 0. Okay, next one is we are moving on to the sum. And then given an expression, okay, and you have to create a sum. After all, in your actually what we are doing is we have to make this, right? We have to make. So we want to give a sum, that is we want to perform a differentiation of the sums, right? Some variables. So this expression we know, that one we are implementing. So that is a make sum. Okay. So the expression sum, in which we are making a expression that is a list, which will be considered here make sum. It is calling the make sum. Make sum is defined what? That is plus symbol and then first operand and then second operand, right? So the list you have to construct. So for the list, what you are doing is make sum of derivation of AddIn of expression. See, look at this one, AddIn of expression. The first argument, okay, from the expression you are filtering out, okay, and calling the same procedure. And if you look at this expression, it is a recursive version. The differentiation is a recursive version, you know. First data you have to take and then the second data, and once again you will check whether it is a constant or not, whether it is a same variable or not. So it is a recursive kind. So for making a sum, okay. So for making a sum, you are once again you are calling the first argument is derivative of the first operand, and then second argument is derivative of the second operand. Okay. So what it will do plus this is derivative of the AddIn first one and then derivative of the second operand, isn't it? Okay. So this is a recursive function. So after all, finally what you will get, sum of the expression, and inside you are making an expression, and finally the summation will be performed. That is the one we have written while writing the sum function. Sorry. So here and there we have to move, otherwise you will not. Okay. See, makes sum. We have used make sum inside. Make sum is making this this list. It is constructing this list. And then what sum does? What sum does for the sum? It should be the pair. This should be the pair. And then car of x. Car of x is plus or not. It is checking, isn't it? So this is for the summation operation, and the same is for the product question mark. It is taking an expression, okay, it is checking whether it is a product or not, and if it is a product, what you are doing inside, multiplier you are extracting and multiplicand you are extracting, right? And then you are applying the formula u into the multiplicand, derivative of multiplicand, u into dv, and then plus v into du, isn't it? So that is a sum part, okay, and you have to make a product as well, and then you have to perform the derivation as well, differentiate as well. So that is why make sum. So make sum will be making a plus, and then two operands. That operand, the first operand is this make product. This is the one. This is the first operand, this result. And second operand is b into du. Okay, so this is for doing a product, differentiation on the product. So if it is, we are not, the thing is, we have many conditions, right? One is a number, and the another one is checking for a variable, and another one is we want to perform plus or not. Another thing is we have to perform product or not. Okay, so if at all something else, division. Okay, for example, some other operation. That operation I didn't incorporate in my procedure, so that it will go to the else part, and then it will raise an exception, unknown expression type. So now, if you joined this session using the laptop, you can just execute and see. Okay, now after seeing all the definition of the procedure, we can call the function. While calling a function, derive, and then this is the expression, and this is a symbol. You just run through the algorithm, what I have explained, I'm taking this input, how it is executed. So this is a complex procedure. Why? Because I have defined many small procedures in the earlier case, and then I'm using it here. So for the first call, what is this? This is a product, or it is a summation, or it is a constant, or both variables are same. So now taking this particular example, if you look at derivation of expression, the expression is nothing but plus x3. So plus x3, and then with respect to variable x. So whether it is a number or not, it is not a number. Whether it is a variable or not, variable of expression, you have one small variable, no. So it is not the expression. What you have is a pair. It is not a variable. It is a pair. So the second condition is false, isn't it? And then coming on to the third one, sum of expression. So the expression contains plus. Yeah, we have the first operand is a plus. Yes, plus symbol you have. So if it is plus, and you will make you will construct a list by extracting AddIn part, and then extracting the organ part, and finding out the derivation, and then you will construct a list. Okay, so the output of this is you will have a list with plus, and then first operand, and then the second operand. Okay, so likewise you can also take this particular input and then check whether you are getting the result or not. So any doubt in this, you can ask me. Actually, you feel bored. This SICP is a boring subject. It's not like that actually.
No, ma'am, nothing like that.
Once you dive into it, you will feel the taste. You want to learn more.
Ma'am, is it like the this SICP? It is just like knowing how we actually got started, no? Like, do we really use the applications in industry? Like, can you tell anything about it?
Yeah, please once again come back.
I was asking like what are the industries? I was just asking. It is just for to this subject is just to improve logic and then implement, or actually it is implemented just like Python, C++, or Golang. It is
Yeah, so I can
implemented.
answer. I can answer for your question. I understood. Actually, why this Lisp language is a little difficult, hard to learn. Why this language? Is there any industry using this one? What is the practical application, etc.? You are asking. So for this, actually, think about there were no languages invented. You don't have a C plus, but it is a very older one, right? So when the people are thinking how to solve the problem using the logic, right? So they were thinking in a different way, and they were trying to formulate a language. It is like a man in a forest, or some crowd is there, and they don't know the language. They don't know any language in a particular country, but they will develop their own language so that the communication is understandable among them. So it is like, so given a hardware, bigger hardware those days and all, there is a bigger hardware computer is there, and we have to program. So they started with Fortran, they have started with a basic language. Basic is one of the language, Fortran is another language for a scientific calculations. And like that slowly they were building the language, right? So as like nowadays there are a lot of computer engineers like that, there were many researchers into this computer field. Everyone are thinking in a different way, right? So if I develop a language, what are the functionality I have to provide? So if I say procedure-oriented language, object-oriented language, inheritance, polymorphism, these are the features. Like that, they were thinking in the fashion of functional programming. How to solve a problem by writing a function and calling a function, etc. It's a kind of different thinking, right? So this is the first language in which many features have been developed. Many features have been developed, and by seeing this, and there is a difficulty in writing, understanding, etc. So that slowly other languages were derived, but they have used the concepts. And this Lisp, there are different varieties of Lisp language. I was working with the Auto Lisp. This Auto Lisp is a programming language for AutoCAD. In the earlier days, I was doing an internship in BHL those days, 1993. So in BHL, they have to draw the boilers and many machines, etc. They have to design it. So for designing, there is a Auto Lisp language. Auto Lisp is the variant of the Lisp language only. So those days they used Lisp language. This kind of CAD drawing and all, and for machine simulations, etc. And nowadays, you are in the internet website, etc., and in which there is no functionality provided. Writing a code in the Lisp and calling the Lisp program in a C#, it is possible. There is no interoperability, isn't it? It's a standalone language. So if you take a .NET, I can write a program in C or C++ or C# or whatever, VC++. I can integrate it. Even I can write in some other language, Java also maybe. I can integrate it. It's a platform independence. But here, this does not have a portability actually. We cannot written a C program. Can you call the C program in a Lisp language? No, there is no facility. But it has its own application actually. And studying the Lisp language, somewhat our thinking processes improved, I feel. Okay, so given the interpreter and how to write, the interpreter will behave in this way only. I want to do a multiplication, I have to write a list with a star and then A, B only, isn't it? So given the constraint, how to develop a procedure? That's what we are doing. So the interpreter has its, yeah.
One more doubt, like JSP hides people for functional programming, no ma'am. What I know. So functional programming is means there is a particular field domain in the industries. What ma'am?
Yeah, earlier days, this is the only one very strong language available. They were using this.
Ma'am, probably Lisp in the initial stages. Now
Yeah.
for the
And in the
functional programming is just using the
class, I
functions,
have
ma'am.
shown you a chart.
Yes,
When
ma'am,
it
yes.
started, now what we have a Dr. Racket, all those. But the versions are not coming out now. There is no improvement. People are not working on this. I think it's fully developed. So people are not thinking why we have to improve something else. Instead, we have other languages coming up, third-party languages are there, so they are not hard coding it.
Okay, ma'am.
But MIT is still, this is one of the curriculum they are teaching. See, this is getting a flavor of the language. So you can, whenever you are learning a new language, that flavor is there or not. You can check, you can appreciate.
Yes.
So
yes.
nowadays, that writing a program in two versions, one was using a recursion, another one using the iterative fashion. So many people quickly they will write a recursive version. The line of codes will be smaller. But iterative version, you have to write a more, right? So any time in the interview, you can also crack the problem using the recursive version. You can write it. That is also appreciated. In some companies, they will say, if you are writing a recursive program, I don't like, it will consume more memory, etc. Like they will say. It all depends on the developer's taste. But I say in the world, any problem can be solved with a recursion. So many programmers, they are specialist in writing any problem using the recursion. They love to write it. So for writing a recursive version, after all, you have to know the commonality, then only you can write, Otherwise, in the iterative version, do this step and then again go to the next step, go to the next step. It will go in a sequential way. But what you are getting is solving the problem in a general way, all right? So that is little difficult. Once you get that expression, for example, you say that factorial of n is nothing but n into factorial of n minus 1. Right. So for solving a problem, what you want, what should be the first data, what should be the next data, so what is the relationship between the data, then how to write the equivalent expression in a recursive way, right? So a small skill is required. Okay, students. Thank you so much. I'm just crossing the time. Okay, so let's meet on Thursday. Thank you, students. Bye.
Thank you so much, ma'am.